All right, team, let's get started on this overview of this second SpriteKit exploration. This is not going to walk you through everything because honestly, the things that I'm asking you to do on each page are not that involved. You should be able to get through this pretty quickly. So I'm just going to do an audio voiceover as we talk about the different pages. This first page does not have anything specific that you are required to do. It's designed to have you look at some of the code and just make some predictions about what you think is going to happen. You can take a look at some of the sprites that are on the screen, take a look at some of their properties, and understand what you think is going to be on the screen when it runs. You also, based on your experience, can look at the touches began function and get an idea of what you think is going to happen in that function. Once you have made some predictions and talked about those predictions with a partner, then you can run the game and just see how close you were. That's all you're looking to do in this first page. In the second page, and the pages after this, you want to actually run the code to see what it does before actually editing anything. As you can see in this one, we have our first text sprite, and it just kind of falls off the screen. And what it says is it's not centered, it doesn't have an interesting title, and it also falls to the platform, which is not something that we want to have it do. So your job is to look at the different properties inside the didMove function and make it so that, number one, the title does not fall from the screen. Number two, change the title to something that you want it to be. And number three, what's the third thing? Center it on the screen so that it appears right in the middle. Page 3 is a score indicator. And in this one, if you run, my screen has what it is supposed to look like when you do it correctly. But in your version, that is not on the screen. So you want to use the content of page 2, the previous text sprite, in order to create that score indicator the way it appears here. I'm going to strongly recommend that you use this name score label as the name of the variable that you store that label node in, because the code later on in the exploration is going to be using that name. We now want to use the score label node from the previous page, and we want to update the score anytime the character moves to a new location. You can see in the comments some of the explanation of how this works. When the user first touches the screen, it runs the touches began function, and anytime you touch the screen, it runs that touches began function as well. Inside the touches began function, which you can see down here, we want to add something to the score. That is 10 points, and then we want to update the text on the score label. Some of the code is already here. You want to comment that out and ultimately change the new value of that score. You're going to want to use string interpolation, which you might remember from last semester, to update that text. This doesn't exactly match what we want to have on the screen, but it should get you in the right direction. In page 5, we're going to move the character around. When a finger drags across the screen to the right or to the left, we want to give the character a velocity in the direction of that drag. Let's run the code. Right now, I am dragging the character to the right by dragging my finger to the right. If I drag my finger to the left, though, you can see nothing actually happens. And if we scroll down, or the touches ended function, only changing the location of the character when I am touching the location on the screen that is greater than 250. And so when that happens, you can see that code right here, I am giving the character sprite a little push to the right. That is a positive number into the velocity of the character. But nothing is happening if I am tapping on the left-hand side. And so your job is to make it so that when you tap on the left-hand side, something happens. Task number 6 is a more intuitive way to move the character. If you tap on either side of the character, then if you tap and drag your finger on the screen, you want it to move in that direction. Now right now, if I am tapping and moving to the right-hand side like this, you can see it's actually going in the opposite direction. Right now, it's not doing what we want. And your job is to go down to the touches moved function and make it so that instead, and it's actually a drag here, so I'm trying to drag the character over. Number 7, we want to make it so that the character can jump. And this time we're going to be doing it for a double tap or a click. If we go to the touches ended function and I run the code, if the tap count is greater than 1, meaning I double click, the character jumps. That the bounciness of the character isn't quite enough. We need to give it more of a push in order to get it to move. If I touch and I kind of drag it as I go, the character jumps and moves to the left. So your task is to change the properties within that jump so that it's possible to get that character up onto the platform with a single jump. Page 8, let's run the code, and you'll see that there's a little thing on the screen. That is the prize, and we want to get the character to get it. I'm going to run over here. You can see that it contacts it, and when it contacts it, the prize disappears, and what we want to have happen is the score goes up. So you can go through here and find the code that runs anytime sprites are in contact with each other. I'm not making it. You're going to want to do that probably right over here would be great. And you're going to be using your code from page 4 where we updated the score in the prize collecting code when the character contacts the prize to make it so that the character score goes up. We're now going to add the start of animation. When the character is moving, we want the character to face the direction of movement. We can look at the pictures that are stored in this playground. One is the character facing the left, one is character kind of walking to the left, character standing to the right, and character walking to the right. What we'd like to do is, when the character is moving left, show the left walk picture, and when the character is moving to the right, show the right walk picture, and otherwise just show the front picture. This is going to be done inside of the didFinishUpdate function. We can actually see that this has the right behavior. In your version of the code, it's not actually working this way. So your job is to fix that code so that it actually works the way you see here on the screen. Page 10 is introducing something that you've actually seen before at the end of last semester, and that was the idea of creating functions for code that fits together. You can see this function draw character. There's code that is missing here that was on the other pages which actually draws the character to the screen. Way down here, there's a function called draw character, and inside of it is all the code that's needed to draw the character to the screen. But there are a few empty functions for drawing the ground, drawing the platform, drawing the score label, and drawing the prize. And your job is to fill those with the appropriate code that right now is up here inside of the didMove function. Page 11 has a moving animation. The code is going to alternate every 0.2 seconds between the standing and walking images so that it looks like it's actually moving to the right and to the left. If we run the code, we can see what that looks like. So as it's moving to the right, see it actually looks like the character is walking. When it stops moving, the character is standing. Right now, we have this funny moonwalking thing happening, which, as cool as it is, we want the character to be walking to the left. And so your job is to fix that in the code. Page 12 is talking about a feature in Swift known as a class. We have created in the code 2 new files in which we've defined sprites, defined properties. So I have made a sprite for the prize. And if we go back to main, we can have 2 prizes on the screen. And each one has the properties that are defined inside the prize.swift file. And down here inside the prizes function, you can see we are setting the properties for each of those prizes once we have created them up above. So we can give each prize a separate location, an X and Y coordinate, and then we can add it to the scene. In the instructions, you want to add a few more prizes to the scene, as many as you like, to complete this task. The last thing that I'm looking for you to do is to actually do the same thing as with the prizes, but using platforms. You can see that there is one platform on the screen. Your job is to create a few more platforms, add some prizes on top of them, and then move the character to collect them. In this one, I will actually just show you. So we have these 2 platforms. Really, everything you need to do for this last task is inside of the draw platforms function, and this will complete this exploration. Now, there is one last thing, and this is sort of the Easter egg for making it to the end. some of you are going to be concerned at how this is stretched, and you don't want this to be stretched. So what we can do is we can go to scene.scale mode, and we can set it to aspect fit. We're going to do aspect fit. As we run this, we're now going to be able to see the entire scene. The prizes are circles, and we can see we don't have any of that stretching happening, which is going to be important for our games moving forward. Thanks for watching. I hope this helps. As always, work with your partner and then work with me if you have any questions. Also, take screenshots as you complete these tasks working with your partner and put them in your SpriteKit Google Slides presentation. Good luck.